Have you ever wondered how engineers calculate how much water is flowing through a pipe? Or how they can predict whether a storage tank will fill up or run out? What about calculating the flow rate for a jet engine or for the cooling system inside a rocket? Even though these systems look completely different, they all follow one simple rule. Mass cannot be created, and it cannot be destroyed. That idea is known as the conservation of mass, and it forms one of the most fundamental principles in engineering. Instead of tracking millions of individual fluid particles, engineers define a fixed region in space called a control volume. We simply observe what enters the control volume, what leaves it, and whether anything changes inside. Now that we have our control volume, we can ask an important question. What are we tracking? The first quantity engineers analyze is mass. Mass is simply the amount of matter contained within a substance. Whether it's water flowing through a pipe, air moving through a ventilation system, or fuel entering a rocket engine, every fluid has mass. One of the most fundamental laws of physics tells us that mass cannot be created or destroyed. It can move, it can accumulate, but it can never simply appear or disappear. This principle is known as the conservation of mass. Let's apply this idea to a simple control volume. Imagine water flowing through a straight pipe. Suppose 1 kilogram of water enters the control volume every second. If the amount of water inside the control volume isn't changing, then 1 kilogram of water must also leave every second. Nothing has disappeared, nothing has been created, the mass simply passes through the control volume. This is the essence of conservation of mass. Every engineering application, from household plumbing to rocket engines, must obey this principle. If the mass entering equals the mass leaving, the amount of mass inside the control volume remains constant. This is called steady flow. If more mass enters than leaves, mass accumulates inside the control volume. The tank fills over time. If more mass leaves than enters, the stored mass decreases. The tank gradually empties. No matter which situation we're analyzing, conservation of mass always applies. Engineers summarize everything we've discussed using a simple mass balance. The rate that mass accumulates inside a control volume is equal to the rate mass enters minus the rate mass leaves. This equation isn't introducing a new physical law. It's simply a mathematical way of expressing conservation of mass. Now consider the special case of steady flow. If the amount of mass inside the control volume never changes, then the accumulation term becomes zero. That means the mass entering the control volume must exactly equal the mass leaving it. So far, we've talked about mass entering every second. Engineers call this quantity the mass flow rate. Instead of measuring how much total mass exists, we measure how quickly that mass is moving through a surface. 3 factors determine the mass flow rate: the density of the fluid, the cross-sectional area of the pipe, and the average velocity of the flow. A larger pipe can carry more mass. A faster-moving fluid transports more mass each second. And a denser fluid carries more mass than a lighter one, even if both move at the same speed. Together, these 3 quantities determine the mass flow rate. When you place your thumb over the end of a garden hose, the opening becomes smaller. To maintain the same mass flow rate, the water speeds up as it exits the hose. The amount of water flowing each second stays nearly the same, only its velocity changes. Now consider a water tower. If more water is pumped into the tower than leaves through the distribution system, the water level rises. If more water leaves than enters, the water level falls. Let's summarize what we've learned. Conservation of mass tells us that mass cannot be created or destroyed. Control volumes allow engineers to analyze fluid systems without tracking every individual particle. Mass entering, mass leaving, and mass accumulating inside a control volume must always balance. And by understanding this simple principle, engineers can analyze everything from household plumbing to aircraft, power plants, and rocket engines. Thanks for watching, and I'll see you in the next one.